So this morning I got two parcels. This is one of them. I had the presence of mind not to open it, so we're going to do an unboxing video. Here we go. So I reckon this is going to be a frequency counter made by the fine British company called Venner. Now, Venner did a lot of things to do with time. They were well known for making time switches back when that was quite a high-tech thing. They made the time switches, mechanical time switches, for the red post office telephone boxes. And they also made this. Some packaging in here, more packaging, and a lot more packaging. That's okay, that's recyclable, that's all good. It has its own lead by the looks of it, rather than having an IEC cable, because it's a bit old for that kind of thing. This is probably from the 1970s. Venner were around in the 60s. I think this is a 70s item. Looks like I'm going to take the instrument out of the box. There we go. Okay, bubble wrap. Fantastic. I found that my local charity shop can accept bubble wrap as a donation, and I do that because I get excess bubble wrap from this kind of thing, and they use it to parcel up charitable purchases that they're sending off to customers in the post. So that's going to be going to them maybe tomorrow. Right. There's a carrying handle on the front here. Now the thing is, I don't know what kind of display this instrument has got. It has a digital display of some kind. I think it's 4 digits. But I don't know what kind. The listing did not show the device powered up. Well, it didn't work for all I know. But that's a minor issue. So I don't know whether it's a Nixie tube display or a Panaplex display or some other kind of display. I'm hoping for some other kind of display because I've got Panaplex and I've got Nixie, and I'm hoping for something else. I'm hoping for something really interesting. I don't know what we're going to get. So, look at the front of it. Here we go. Hope this will focus okay. This is it, the digital timer, type TSA240. Quite small displays. Lovely British GPO telephone style switch there. 2 of them. Reset there, and display update time supply off, 12 volts mains. Yep, that's quite substantial. Let's zoom a little bit closer on that for a moment. There we go. We've got a mode switch by the looks of it there. Start and stop. So it's a timer. So it doesn't necessarily measure frequency, although it might have a mode that will do that. It has a start and a stop signal. And it's got the 4-digit display. A little bit dusty. It smells slightly like it's been in storage for a while. But let's find out what happens when I switch it on. And yeah, let's just find out what happens when we switch it on. We have got on the side here some fixing screws for the lid, the top and bottom halves there. What's on the back? There's the 12 volt power in. There's the mains in, 240 volt AC. An external reset signal there. A couple of fuses. Right, so Venner, a division of AMF International. Now AMF, American Metal Foundries, I think. Kingston Bypass, New Malden, Surrey. So that's made in England, but the parent company was AMF. I got an idea. AMF bought a number of industries, a number of companies. One of them, I think, made pinball machines or pin setting machines. I've got a suspicion that they bought Harley Davidson at one point. Okay, switch it on. Right, the plug is in. Nothing's happened yet. That's surprising. Oh, just switch it on. Oh, look at that. That is a projection display. Oh, now I took a chance with this. Made the vendor an offer. He accepted it. I accepted his counter offer. Yeah, I didn't know what was going to happen when I turned that on. And what we've got there is some kind of projection display. And I can tell it's a projection display for two basic reasons. Firstly, it looks the right colour for a tungsten light bulb. So they're just a little bit orangey yellow. This light is daylight balanced, so they look a little bit orangey yellow. The other reason I can think it's a projection display is that the digits are fully formed, smooth curves. There's no sign of pixels, and there's no sign of an orange Nixie tube or a 7-segment. These are fully formed digits. Reset. Oh, reset helps, doesn't it? There we go. That's showing this one's actually lighting up as well, so I haven't got a blown bulb. If it's a projection display, then we don't know yet whether it's one light bulb per digit, so one for the 0, one for the 1, one for the 2. So 10 light bulbs plus a decimal point, 11 light bulbs per digit, or whether it's the kind of projection display where there's a single light bulb and the light photographic slides or negatives, the masks that produce the digits, whether there's something that moves the mask in front of a single projector light bulb. Don't know yet. We'll have a look inside in a moment. Oh, there's a 1. Now, whenever it changes, it goes out. It goes blank. Just briefly. Resets to 0, okay. Well, this is very interesting. But every time that digit changes, it goes blank, just briefly, and comes back on again. So I can't tell whether it's going out and then moving the mask, or the sort of negative or slide, if you will, if it's a photographic projector, or whether it's simply lighting up a different light bulb and it's leaving just a little time delay between light bulbs. I haven't got the right gear at the moment to give it pulses. I think that's what these are for. Let's open it up. Okay, switch off. And unplug. And I should have prepared a screwdriver, but I foolishly did not, and it's just the other side of the camera. It'll be a short pause while I go and get the every screwdriver in the box. Right, if that won't shift it. Okay, that was easy, wasn't it? So we've got two ordinary screws here. Let's just remove the top one. Same on the other side. Oh, someone's been in here. That screw's an odd one. There's a Phillips screw in the bottom there. I wonder if that's sufficient. Yep. Now, we should be able to tell by the number of wires on the back of each digit whether it's a light bulb per digit. So there'd be 10 or 11 or 12 maybe light bulbs, so there'd be a lot of wires. If it's a single light bulb and a projector arrangement with a moving, maybe a moving coil setup, there'll be fewer wires. Now, let's just lay that down. I think we've got quite a lot of wires in there. I think the back of each digit has got enough wires for this to be one light bulb per digit. That's a bit of an issue, because if it is one light bulb per digit, then if one of them's blown, I wouldn't know yet, I haven't seen all the digits yet, but if one of them's blown, that digit in that digit position won't light up. Let's say the 3 in this digit position might have a blown bulb, and I won't know until I try and light up a 3 in that position, and I'll find it goes blank, and I'll have to get this apart, take out that particular digit and fit a new bulb. But I've first got to buy a new bulb, so that could be an issue. If these are individual bulbs, they may need replacement. What else can we see in this thing? Big mains transformer, big 50 Hertz iron core mains transformer. No switch mode power supplies here, thank you very much. It's all iron cores, rectifier, big smoothing capacitor in the bottom here. That will have a date code on, most likely somewhere, if I can find one. That's the bridge rectifier by the looks of it. Looking for a date code, absolutely. Can't see one off top, from the top here like this. Date code would generally be a 4-digit number, something like 7327, which would be 1973, week 27. But I haven't seen anything yet. This is a crystal. Now, I've got another video on YouTube which shows a crystal in a glass package like this. Here's one in use. It's made by GEC by the looks of it. I'm going to attempt to remove that board from the chassis. Oh, there it goes. Yep. Okay. That just comes out like that. Lovely. So there's our little gold edge connector fingers there. Oscillator. There we go. So we've got a crystal, 100 kilohertz, made by GEC. Oscillator. Aha! Now we have got a date code. Let's get that a bit closer if we can. Let's see if it'll manage to focus if we get that a bit closer. There we go. So that shows a little bit more of the... There we go. The crystal, 100 kilohertz, GEC, but we've got some chips. So it's not that old. It's newer than, let's say, 1970, because chips in 1970 were the kind of thing that Apollo could afford to go to the moon with, but it wouldn't be in something like this. Let's just flip that over. And we have got a date code on here. This is a good old-fashioned Texas Instruments SN7400 N. So that's a quad 2-input NAND gate. Absolutely standard stuff. And it's got a date code of 7532. So as I suspected, we've got a 4-digit date code there. 1975, week 32. So that dates it rather nicely. Let's just turn that around. You can see the GEC on the crystal there, 100 kilohertz. Made in England, it says on the label. Don't see that anymore. There's a preset there for adjusting something. I don't know what that's for. Standard looking 1970s components, absolutely what you'd expect to see. Looks really good. Looks like it's clean and tidy, no problems with that. I can't tell yet whether it actually works, but the thing didn't behave too crazily when we turned it on, so I think we have a reasonable chance that this is going to be okay. Put that back in there. The colour coding of the different boards, so there's a red board, possibly the input circuit, then we've got 4 the same. Now it's got 4 digits, so I'm going to assume that these are the 4-digit drivers. Let's have a look and see what they look like. Yep. Oh yes, look at that. Counter. Digital timer counter. Now this again confirms that we've got individual light bulbs per digit in the display, because we've got 10 transistors here, TR1 to TR10. So we've got a transistor per light bulb. So these are going to be driving each individual light bulb through the wiring loom. There's a lot of wires in this thing, but driving these is a couple more chips. Now what are they? Oh, now those I don't recognise. SGS is the manufacturer. So that's SGS Thompson, or what's now called ST Microelectronics. The S of ST is SGS. I believe that's either French or Italian. I couldn't tell you which, because that's the 2 nations that comprise ST, I believe. Yeah, very interesting stuff. A 2N3053, which is on a heatsink, medium power transistor. What are these? What does it say? Oh, no. All they've got written on them is V763. So they are proprietary house-coded parts. I don't know what they are. But okay, so that's, I think, confirmed that we've got 1 light bulb per digit. So there's a light bulb for 0, light bulb for 1, light bulb for 2, and so on. And one of them will light up to make a digit display on a little display. So I am very pleased with this. I think that's probably about it for this particular video. Very pleased to find that it has got a display that is not a Nixie tube, not a Panaplex, not something that I've already got. This is a type of display that I have not already got. It's a projection display. I've got a projection display in another Venner counter, which I have another video showing it, that doesn't work, and that's the type with a single projection light bulb and a moving digit mask. So you can see the digit masks move across the projection screen at the front. This one, pretty sure, has got, well, given that there are 10 transistors, it's got 1 light bulb per digit. So there's 40 light bulbs in there for the 4 digits. It looks okay. I need to set up a means of testing this. And once I've done that, I'll make another video which shows the thing operating, and we'll get a good close-up of that display. So that's about it for the unboxing video. I think I will leave it at that. And as I say, very pleased to see that it's a projection display of a type that I've not seen before, and I hope I can get this thing to produce an interesting display using some sort of pulse generator. I think will be the way to go. Anyway, there we have it, the very fine Venner digital timer type TSA240.